Hi everyone, welcome to another video. In this video, we are going to discuss problem number 1365 of LeetCode, which says how many numbers are smaller than the current number in an array. So let's first see what is the question all about. So we are given an array called as nums, and for each element in the num, we have to find out how many numbers in that array are smaller than it. So for example, if you see in the sample test case, we have an array nums which has 8, 1, 2, 2, 3. Now we have to return another array which is obviously of the same length, but instead of the elements, it should have the count of each element in the nums array. So for example, here 8 is the first element. So we have to see how many numbers in this array are smaller than 8. So you can see that 1, 2, 3, 4. 4 is the count of the numbers which is smaller than 8, and that's why in the resulting array, in our result array, in the same index as of this element 8, we have to return 4, and it's similar for every other element as well. Uh, if you want, you can pause the video and see the explanation as well, and we have some more examples also. So to start off, we'll just first see what is the brute force approach like. Okay, so obviously we have to return another array, so we can initialize it as answer, int answer equal to new int answer, which is of the same length. Now obviously we have to traverse the array. Without it we cannot really start, so we'll just traverse this array I plus plus, and then we have to do something here. Okay, but if you see carefully, you have to use nested loops in order for you to compare one element with all the other elements in the array, right? This is the brute force approach, by the way. There is another method which we will discuss later, but so we have to make another loop, and it has to traverse to the whole length only, and j plus plus. Now what we'll see, we'll say if nums of I, which is the current element that we are uh, pivoting pivoting at currently. So let's say in this array it's 8. Now we'll see if 8 is greater than nums of j. Why j? Because j is actually the one pivot which is traveling all across when we are standing still at our element. J is the one which is traveling all across. So yeah, if it is greater, then we have to do something. We have to basically increase the count. So first we have to declare the count variable and initialize it to 0, and then we have to increase it, right? And then next what we'll do, we'll say count plus plus, and yeah, we have to assign that count variable into answer array, right? So answer of I, because we need the same index, and that index is basically I at the moment in the loop, and we have to simply say count. And so let's see a dry run manually first. For example, I'm on 8, 1, 2, 2, 3, right? We have to return what? We'll just see. So we'll just put commas for now. 4 commas, I believe. Yeah. Now we are at 8. Okay, count is 0. For I equal to 0, that means we are at 8. This is the number, by the way. And j equals to 0, j up to length. That means j will be traveling from 0 to nums.length, that is 5, right? So once we increase, okay, now we are at j. Now we are at 0 again. 8 is greater than 8. false. So we don't do anything. Now j plus plus 1, 8 is greater than 1, true, then count becomes 1, and answer is something like, yeah, answer is looking something like this. For now here it is 0, because in Java it will be initialized as 0. Am I correct? Yeah. So what answer looks like this. Then we move on to next. 8 is greater than 2. That means correct. Count plus plus. Then this 1 becomes 2. Now 8 is again next. 8 is greater than 2 again. Yes. Then this 2 becomes 3. And 8 is greater than 3 again. Then this becomes 4. Now what we'll do? We'll come back to our I for loop. This is I, right? I will become 1. That means we move to 1. Now we'll again check. Oh, but one thing, wait. The count is initialized only 1 as 0. So what happened is, now we have reached count to 4, but we are not resetting that count, correct? So we should initialize that count here, because for every element we need to reset it, right? Oh, sorry. So it is reset now. Now count will again 0. Sorry, here it's not something 0. Here it is 0. So we are at 1. Then we again traverse the J loop. 1 is greater than 8, false, no, do nothing. 1 is greater than 1, false, do nothing. 1 is greater than 2, false, do nothing. 1 is greater than 2, false, do nothing. 1 is greater than 3, do false, nothing. So this remains as it is, 0. Again we change the I, and like this is it goes like, okay. Now if we try to run it, let's see if the answer is correct or not. Cool, this is correct, and let's run it. So yeah, it is accepted. So basically we have got our brute force solution. But here if you see, here if you observe, let me just remove the comments for better readability. Yeah, here if you observe, the time complexity of this solution is pathetic. It is big O of n square. So we don't want that, obviously. It is not a time complexity that we should be hoping from a programmatic solution. So in the next part of the video, we'll be looking at the better solution, which has much better time complexity than this one. So let's see. So we have seen the brute force solution, and we want to obviously improvise our approach and reduce the time complexity eventually. So let's start working on that better solution. So first of all, we need to return an array, right? So let's make an array first. So it will be int answer, and I'm just making a copy using the clone method in Java, copy of the nums array, and then I'll return the answer array. Now I would like to sort this array. Why? Because if you see, in this sentence we have got our answer array, and let's say it is similar to that simple test case. It's 8 1 2 2 3. Now if we sort it, what will it become? It's pretty obvious. It should look like this: 1 2 2 3 8, right? Earlier, if you noticed, we were returning 4 for 8. As you can see, the output should be 4 for 8 and 0 for 1. If you carefully observe here, the index of 8 is 4, the index of 1 is 0, like that, like so. And that is our answer. Basically, we need to return the index of the elements of an array by the help of a sorted array, basically. And obviously, we are using a map to keep track of that index, right? So let's create a map as well, because it will be used. Map of integer key and an integer value, and I'll call it my map equal to new hash map. Okay, let's start our traversing our So let's start putting values into our map first, obviously, right? So we'll traverse our answer array. So I'll just say my map dot put if absent, and I'll just put answer of I, and the index as the value. What it will give to me? It will just say 1 is 0, 2 is 1, 3 2, since 2 are duplicates, that's why 2 will be 1 only. It will not be like 2 2, right? Map doesn't allow duplicate keys. 3 will be, I think, 0 1 2 3, and then 8 will be 4. If we can notice now that we have actually got our answer, but we just need to make use of this map to get the hold of those values of the map, right? So for that we have to traverse the array once again, and this time I'm using nums array, and I'll just we have to return an array, so we'll just say answer of I equals to now we have to make the use of a map, our map that is now having our answers, my map dot get, and then nums of I. So here what is happening, I'll just put a semicolon, and here, yeah. So if you just try to do a dry run, let's say for I equal to 0, so what it is asking, answer of 0 equals to my map of nums of 0. That means my map dot get 8, right? So my map dot get 8 means my give me the value of the key 8, that means 4. So what does answer become now? 4. In the next iteration it will become my map dot get 1, that means 0. Next my map dot get 2, that means 1. It will be same for the next iteration as well, because we have 2 as well, 2 again, right? And then for 3 it is 3. And if you just see here in the sample output, it's the same. So let's try to run it. Have I made any mistake? No, hope not. Yep. Okay, it ran. Okay, so and also the time complexity is now big O of n log n, so it's obviously better than big O of n square. So yeah, this was it, and I hope it was of some help, and always a learner. Thank you. I'll see you soon in the next video. Bye bye.